So let's check on the analytical solution and see how the match is for the diffusion problem. I'm going to first go back to the the zero frame that represents the initial condition for the problem, so we can be sure exactly how large the initial slug was. And I'll use this line tool to measure. So it looks like it's 4 lattice units across. That means that the M0, which is the initial mass, is going to be a value of 4 mass units, because we have 4 lattice units filled with a density of diffusing material at 1, concentration of 1, basically. The analytical solution for this problem is the concentration as a function of time and space equals some background or initial concentration. In our case it's 0. The initial mass is going to be 4 over 2 pi. The diffusion coefficient is given by tau for the second component, also known as tau 1 in the input file, which we've left at 1, in which case the diffusion coefficient ends up being 1/6. And that should allow us to solve this problem. One thing we need to do is to collect the numerical data from the slice file. This isn't too difficult. We'll look here at a slice for frame 11. And you can see that it contains all of the information that we're going to need. So row slice for component 0, and then row slice for component 1. This is the information that we need. Just for simplicity, I'm going to copy it. Actually, I think first I will turn this off of word wrap, if that's what's going on. I guess it must not be. So I'll just pick the row slice data. There should be 201 points here. Okay. For simplicity, I'm just going to paste these into Excel. I've already computed there the analytical solution. Let me paste this right here. It looks as if it has not been parsed, so I will need to do text to columns. And it's probably safe to use a uniform width. It looks pretty good. Okay, now the analytical solution I've only solved at length or distance units of 2, 4, 6, and 8, and at a time of 1100. So let's see. This one runs actually from minus 200 in steps of 1 lattice unit, minus 199. I'll just put these in explicitly and drag to fill here, and then we'll be able to plot them. Okay, so start the plot with this solution. This is the numerical solution. Oh, I guess I've not done that quite right. This should begin at minus 100 and run to plus 100. Let me fix that. Okay, and now we have a chart that is centered on 0. Now let's copy in the analytical solution. Let me move this chart back. Copying the data, go over and find the chart again. I'll just edit paste special with the categories in the first row. And we've only solved this part of the equation here. Let me change the formatting of this. My preference is always for analytical solutions, no markers, and a solid line. And let me also edit the other solution, the numerical solution. So that we're able to see the analytical solution underneath. And we can see that it's quite a good solution. So series 1 is the numerical and series 2 is the analytical.